Properties of the Earth. This is the first set of notes for our astronomy unit. We're going to start by looking at our home in space, the Earth, move out to the moon, to the solar system, and then off to interplanetary space. But first, let's start with our home, the Earth. We're going to go over a couple properties about it, explain why we have seasons, and then we will move on to the moon next week. So our first property of the Earth is what's called its rotation, which is the spin of the Earth on its axis. So rotation is the spin of the Earth on its axis. Right? This takes 24 hours to go all the way around. Each rotation is 1 day. So one rotation takes 24 hours. All right, so we move into, as the Earth rotates, you move into and out of the sunlight, and this causes day and night. All right, that's rotation, pretty self-explanatory. The next one, which is a similar name but means something very different, is revolution. It's easy to get these a little mixed up, but revolution is the movement of the Earth around the sun. Right? And this takes about a little over 1 year, 365 and a quarter days. So the revolution is the path of the Earth that it takes as it goes around the sun. While it's revolving, it's also rotating. Right? So as the Earth is revolving around the sun, it's also spinning on its axis throughout the whole process. Right? The path of the motion, the path of the Earth around the sun, is called the orbit. So that's the name of the path. This dotted line in the diagram, we would call that the orbit of the Earth. Right? And one revolution takes 365 and a quarter days. Right? Every 4 years, we add up those quarter days and we add an extra year to the calendar to kind of reset our calendar and make sure that our months are on at the same time each year. So we call that a leap year. Every 4 years, we kind of take into account those quarter days that have added up, and we just add an extra day every 4 years to rebalance the calendar. So that's where a leap year comes from. The next thing, and this is what we're going to kind of focus on for the rest of the notes today, is that the Earth is tilted. So the tilt of the Earth. So the Earth is tilted on its axis. So the Earth is tilted relative to its orbit. So the axis, the line between the North and South Pole, right, which we can see here, this line right here, so you can see the South Pole down here, the North Pole up here, isn't straight up and down compared to the Earth's orbit. It's tilted, which means sometimes the North Pole is tilted towards the sun, sometimes the South Pole is tilted towards the sun. And this tilt causes the seasons. So if the North Pole is tilted towards the sun, this equals summer in the northern hemisphere. If the South Pole is still tilted towards the sun, this would mean winter in the northern hemisphere. And it would be summer in the southern hemisphere. Right? And so this tilt ends up causing our seasons. And so our next slide has a good diagram of this. Right? The Earth is always tilted in the same direction as it orbits the sun. So the North Pole is always pointed the same way. So as we rotate, or as we revolve rather, around the sun, sometimes the North Pole is pointed away from the sun, like here during winter. 6 months later, we've gone halfway around our orbit, and now the North Pole is tilted towards the sun. Right? And this would be our summer season. As you may have figured out by now, this means that the southern hemisphere has opposite seasons from us. We'll talk more about that in a second. So, the days when the Earth's pole, when either pole is tilted most towards the sun, is called a solstice. So a solstice is a day when either the North or South Pole is tilted the most towards the sun. All right, and so this is the start of summer for one hemisphere and the start of winter for the other. So our summer solstice is on June 24th, or June rather 20th or 21st in the northern hemisphere. And our winter solstice is December 20th or 21st. And which day it is kind of depends just on how the Earth is moving through its orbit that year. Whether we've had a leap year that year will affect whether it's the 20th or the 21st. And it's the opposite seasons in the southern hemisphere. So if you go to South America for Christmas, they're actually having summer. So they have Christmas in their summertime, right? Christmas is still December 25th every year, no matter where you are in the world. But if you live in the southern hemisphere, you live in South America, or you live in Australia, Christmas happens at the beginning of summer rather than the beginning of winter, which is kind of a weird thing, but that's the way it works because of the tilt of the Earth. And then our other important dates are called equinoxes. And this is the start or the end of spring and fall. So an equinox is when the sun is a day when the sun is directly above the equator, right? So neither pole is tilted towards the sun. We have our vernal equinox, which is the start of spring, and our autumnal equinox is the start of autumn. Again, these are opposite in the opposite hemispheres. So in the southern hemisphere, our vernal equinox would be the southern hemisphere's autumnal equinox. Our autumnal equinox, the start of our autumn, would be the southern hemisphere's vernal equinox, the start of their spring. So that's what we have for properties of the Earth. Hopefully you have now a good understanding of where seasons come from. Just realized I misspelled solstices in the middle. There we go. Fixed that. Please make sure you write a good summary on your notes. All right, a lot of us lost points on our last notebook because we didn't write summaries of our notes. So make sure you write a good summary, do a reflection, and fill out the survey online. And I will see you in class tomorrow.